So the idea here is that that when you have an angle, we have two different kind of things going on in this diagram, and for these problems they're the exact same, which is the angle formed at the center of the circle, and then the arc that's traced along the outside. And the idea is that the measurements of that angle and this arc that's traced around is the same. So if this is 70, this is 70. So that's all you're doing on the first couple questions is, oh, these two are the same. That's all you're doing, 1, 2, and 3. And just reinforcing the idea that when we talk about the angle, when we talk about the arc, those are the same. Now, when you get to number 4, you're going to start using a little bit of a different idea. And there's going to be two main ideas that you're going to be using, which is, I'll list them out here. So two things you want to look for. Number 1 is to look for going all the way around the circle. Because we know that all the way around a circle is going to be 360 degrees. So we know all the way around the circle is 360 degrees. Thing number 2 you can look for, which is what we're going to use in this problem, look for a diameter. Because the diameter is halfway around the circle. And so halfway around 360 degrees is going to be 180 degrees, which, as I said in the notes, that should make sense because a diameter is going to form a straight line. And we know that a straight line is 180 degrees. So that's what's going to help us here. Most of your equations are either going to be revolving around using a diameter and adding those measurements up to 180, or you're going to use the fact that all the way around the circle is 360 degrees. And so add up all the measurements you're looking for, they should add to 360. Now, there are some that are different than that, and we'll get to them, but that's the basic idea of a lot of them. So those are the two things that you should be looking for in this problem, on these problems. All the way around the circle is 360, and then halfway around is 180. So I've traced out the diameter, but I'm going to trace it out again just so that you can see it again. So on number 4, your diameter that's halfway around, there are two different diameters in this one, but the one that's going to help us the most is this diameter, W to Z. Because that's going to help us get X to Y. X to Y is saying this is our starting point, this is our ending point. So we're looking for this arc. And we know that that's also equal to this angle. So if I take the 70 degrees, plus the X to Y that we're looking for, that we don't know, plus the 61, then we have to get 180. We have to get 180 because that'll get us halfway around the circle. So then we solve that. I'm not going to solve all of these. Mostly going to focus on getting you set up. But we'd combine these together. We would subtract. And then we get 49. So 49 degrees is your answer. So it's this idea of working us halfway around the circle and figuring out how much that would need to be for it to be for it to match up to 180 degrees. Now, sometimes you want to pay attention to the measurement that you're being asked to find. So here you're being asked to find the measure of angle TQV. And TQV is this angle right here, T to Q to V. And so you want to, you know this is 61, so you want to figure out what this is. And you're going to use a diameter to do that. You're going to figure out what this is and then add it to the 61 to get the total measurement. And then sometimes you're going to get an even bigger measurement. So let's look at number 6. Any questions on number 4 before I go on to number 6? How do you know which one to find? It says so. It says so at the top here. It's got measure of x to y. So you look at what you're trying to find, and you're saying, oh, well, I've got these two measurements, and it's kind of a notice. It's kind of a notice which piece you've got and which things you know. And if I combine those, what do I get? Well, if I put this measurement that I know, and then this measurement that I'm interested in, and then this one that I know together, oh, that takes me halfway around. It's just being able to notice that idea. A similar thing happens here. So it's about taking stock of what you know, and then take stock of what you're trying to find and what you're interested in, and put those together and see what you get. Let's look at another example to see how we're gonna work that out. So here's what I have. I have LJM, and this is I said this in the notes, but these 3 letters means that I'm looking for a major arc. Major arc just means that it's the larger arc than what we would normally be our go-to. So normally our go-to is to, if I'm going from L to M, then I would go from L straight over to M. But the major arc set, my 3 letters, says that I have to travel the long distance all the way around to get to M. So that means that I start at L, and the J being in the middle says that I have to go through J to get to M. So L, trace all the way around, have to pass through J on my path to M. So it traces out the path. If I just wanted the smaller one, then I would just say LM, and that would be my arc. So again, take stock of what you are trying to find and what you know. You know that this is 65. You also know that this is 65, but the more helpful thing is that here's what I'm trying to find, and here's what I know, and we've gone all the way around the circle. So when you trace that out, you might start to find that tracing that out will give you either all the way around the circle or halfway around the circle. In this case, it gives me all the way around. So if I take the thing I'm trying to find and add the 65, this measurement here, then I get all the way around the circle. And that'll give me the measurement I'm looking for. And yes, it'll be a big number, which should make sense because a 360 is all the way around. This is pretty far around the circle. So it should be an answer of 200 and something actually does make sense in this problem. So there's an example where we're working all the way around the circle. Now I'm going to pause here to see if we have any questions. And I want you to also, while I'm doing that, I want you to look at numbers 8 and 9 and see if you can figure out which piece of information is going to help us and how we're going to set up the equation. So again, even though there's more complicated expressions going on here in 8 and 9, the key idea is that we're going to trace out the parts that we know and what we're trying to find and see how far we get around the circle. And that's going to inform what equation we set up and what we add together. What numbers are we adding together? We're adding the numbers that we're told, basically. So if I trace out what I know this 72. I know that measurement is 72. I know this measurement is 55. And I know this measurement is 7x plus 4. So this is the part that I'm trying to find. And so if I trace out that arc around the circle, then I reach a diameter. And so you see how we either work our way around a diameter or work our way all the way around the circle. Like these are the most common types of equations. Here's a diameter. So that means diameter going halfway around is going to measure 180 if I put all those pieces together. So if I put the 72 and then I went through the 55, I'm just recapping the arc that I traced around. I went the 72 and then I traced the 55 and then I trace the 7x plus 4. Add those all together to get 180. And then you're going to solve. Now, over on number 9, let's trace out the things that we know. And we can start anywhere. I'll start here and work clockwise around. We've got a 43 here. We've got 45. And we've got 160. We know that. We know the 40. And we are trying to find the 10x plus 2. And we have traced, we've traced all the way around the circle. All the way around the circle is 360 degrees. So all I need to do is just add all these parts together, and it's going to give me 300 all the way around the circle, 360. So I started by tracing the 43, and then I traced around the 45, and then I traced around the 160, and then I traced around the 40, and then I traced around, I'm running out of room here, and I traced around the 10x plus 2. And if I combine all those together, if I add all those together, I should get 360 degrees. So it's just tracing our way all the way around the circle, and it adds up to 360 degrees. Or trace our way halfway around the circle if we have a diameter. We don't have a diameter in this one. We don't have something that takes us exactly halfway, right? Because this is at an angle. This is not a straight line. This is the closest we have to a diameter. This one isn't a straight line diameter either. It's got to be a diameter. A diameter has to be a straight line from one end of the circle to the other, and it's got to pass through the center to be a diameter. So these pass through the center, but they aren't straight line segments from one end to the other. Not a straight line from one end to the other. Feel free to give other questions or thoughts as you have them. I'm not going to spend much time solving these equations. I think you can solve an equation like this. On your own. And so again, the rest of these setups involve either finding a way to work your way halfway around the circle, or finding a way to work your way all the way around the circle.
Mr. Hoffman, I have a question.
Yes.
Okay, so like for instance, number 10, so
Number
you would
10.
trace, yeah, you would trace from the 58 to the 43.
Okay.
Then there's nothing after the 43, and then there's 6x plus 4, but then there's nothing after that. So how would you like trace that? Or like,
Oh, okay. This is one of the only ones that's different. This is a good question. So we have the 58 and the 43. The last thing that you might be looking for, and I had one of these in the notes, is that you can have, I've got a straight line here, and I've got a straight line here. So I've got two different diameters. But what this also gives is, let me trace it out separately over here, is that I've got two segments, and basically I know that this is 58, and I know that this is 6x plus 4. And so because these are both straight lines, then these two angles are just vertical angles. And vertical angles are congruent. And so I can just say that the 6x plus 4 and the 58 are the same. I think this is the only one that uses the vertical angles. The rest of these, you just trace them around. But look back in the notes if you want to see another example of using these vertical angles being congruent. So here's the vertical angles right here in the diagram. If you wanted to trace your way around without the vertical angles, there's actually another way to do this. So you could use this diameter and trace your way around and say, oh, that's a bad tracing, but this is 58 and this is 43. So 58 plus 43. And then I got a question mark. I don't know what this is. I don't want to use X because I'm using X down here. Plus whatever this is should go halfway around. And so that should tell you what this is. That means that if I subtract, that would be, let's see, real quick, 101, so 79. This has to be 79. And then I could use the other diameter to trace my way around. So I've got a 43, and I've got a 79, and I've got a 6x plus 4. And this is another diameter that also works my way halfway around the circle, 43 and 79. And this 6x plus 4. And now we have an equation for the x that we're actually trying to solve for. So you can still do it with diameters. It's just different ways to get there. There's actually two different steps of tracing your way around that you have to take. So what you should be looking for if you're looking for tracing diameters, you should be looking for, I know all of them but one. And then I know all of them but one. So I know the 58 and the 43. I don't know this one. Well, if I know everything but one thing that I don't know, then I can solve for it. And then that gives me another measurement of 79. So I know everything except for this one thing I don't know. I could even use that another way. I could even use that diameter. And I'm doing this just so that you get practice with being able to see these and visualize these diameters. I could even use that to trace around the other way. This is also halfway around the circle. So I'll call this Y because I don't want to use X again. And I don't want to use question mark again. But if I go 58 in this Y, then I should also get 180 degrees halfway around. I know this measurement, but I don't know this measurement. So that means I can find it. Okay, let's do one more. And since since you're probably sick of diameters after that one, let's do one where you're tracing all the way around, just so that we practice one of those. And I'll do this all the way out because I want to make sure that we know how to find the measure of the angle or arc, because you actually have to plug in and find the measure of the arc. So let's see what we know. Trace our way around. Here's 40. Here's 55. Here's 50. Here's 11x plus 1. Here's 12x plus 7. And oh, there we have it. We've gone all the way around the circle. So all the way around the circle is 360 degrees. So we just need to put them all together, add them all up to 360. So I'm going to leave myself a ton of room here. I've got a 40, and I've got a 55, and I've got a 50, and I've got an 11x plus 1, and I've got a 12x plus 7. And I'm back at the 40 I started with. So that's all the way around, 360 degrees. So we're going to solve that equation. I'm getting that this is 153 when I add all these, because this is 105, 145, 146, 153. Okay. And then I have 11x here and a 12x here. 11x and 12x, that gives me 23x equals 360. So then I'm going to subtract. Again, this part, my thought is that we probably don't need a ton of help with the solving. 207. That's going to be 9, isn't it? Yes. So we get x to be 9, but we're not done yet because it wants the measurement of arc T to U. TU. And since it's just 2 letters, it is tracing the path directly from T to U, shortest path. So T straight to U. Well, that is 11x plus 1. So now that I have my solution for x, I can plug it in. Like a lot of what we did at the beginning of the year. Take our answer, plug it in to find a measurement. Plug it in for x to find a measurement. And so what did we get for x? Well, we got 9. So we're going to plug 9 in. Uh, 99 and 1, that's 100 degrees. And there's our final answer. So once you get an answer, then you're going to look at what angle or arc are they looking for. Remember, those are kind of interchangeable. So UPQ means that we're looking for this angle. So you're going to plug it into the 12x plus 2 once you solve for x. UZY, so U to Z to Y is this part, and then H to I is here. Pay attention to the negatives on this last one.